In question number 1, children, figure 1.1 is the distance time graph for a moving car. Along the y-axis we have distance, and along the x-axis you can see the time is there. Look at the graph, and on figure 1.1 mark a point P where the acceleration of the car is 0. Where is the acceleration of the car is 0? 10th class. Jarvis, where is the acceleration of the car is 0 on this graph? Okay, Muhammad Kinan. Uh, Jarvis, no response from Jarvis. Anushka Bedi,
Yes, sir.
this question number 1A. Jonathan,
When speed is constant, the acceleration is zero.
where is the speed constant?
The gradient, so from 0 to 30 seconds, that's when the speed was constant.
Yes, children, this is the distance versus time graph. And in a distance versus time graph, this straight line up to 30 seconds here, it's showing that the object is moving with a constant speed. From time interval 0 to 30 seconds, object is moving with a constant speed. So anywhere in this time interval, anywhere on this line between time interval 0 to 30 seconds, acceleration of the object will be 0. Okay, Shania noted. Now the next one, determine the speed of the car at time t equal to 15 seconds. Find the speed of the car at time t equal to 15 seconds, children. And this question is for Nicolin. Find the speed of the car when time t equal to 15 seconds.
Sir, I think the distance is 75 meter. So 75 divided by 15, which is equal to 5 meters per second.
Yes, sir. 5 meters per second.
This one, right?
Yes, sir.
So this is
Yes,
how
sir.
10, 20, 30, 40, 50, 60, 70, yeah, 75, correct. So 75 divided by 15 is how much?
Is equal to 5, sir.
5.
5. So that is speed. You know, speed, to calculate speed from the distance time graph, you need to calculate gradient. Next one. The average speed of the car between time 30 seconds and time 45 seconds is what? Average speed of the car between time equal to 30 seconds and 45 seconds. 30 seconds and 45 seconds, children. 30 seconds, and this one is a 45. In between this, average speed is what? Average speed is what,
So,
children?
average speed is total distance upon total time, right?
Total
So
distance.
300 divided by 45.
What is the total distance between time 30 to 45 seconds?
But
So will it be like change in distance divided by change in time?
so 150 divided by 150 divided by 15, which is equal to 10,
Can I
10
children
meter per second.
average speed to calculate the average speed? What you can do?
Sir, I did 300 minus 150 divided by 45 minus 30, which is equal to 10 meters per second.
Average speed equal to total distance upon time, total time taken, or displacement upon time taken. So here the 300 minus this much is how much? 150, and the time interval 45 minus 30. 150 divided by 15 is how much? 10.
10.
So
10, sir.
meter per second. That is the answer. Jarvis at 10 meter per second. Next one. After time t equal to 45 seconds, car starts to deaccelerate. Deaccelerates means, children, someone has applied a brake and the speed of the car is now slowing down. Slowing down. At exactly time t equal to 45 seconds, the car starts to deaccelerate, and at time t equal to 55 seconds and at a distance of 400 meters from the starting point, the car stops and remains stationary for 5 seconds. How will you draw the graph, children? On figure 1.1, draw a possible continuations of the distance time graph. Time t equal to 45 seconds and at t equal to 55 until 400 meter. You need to read the statement carefully, children. Let me go back again. At time t equal to 45 seconds, the car starts to deaccelerate. Then, if it is deaccelerating, how would you plot a graph, children? After 45 seconds,
Downward slope.
downward slope means speed object is slowing down.
Yes, sir.
Can I draw a curve here like this?
Yes,
Is
sir.
it? Hmm?
Yeah.
Oh, yeah.
The gradient is decreasing now. The slope is you can't draw a line like this. You can't draw a curve like this. It is showing the increase in gradient. But as the question is the speed is decreasing, gradient should be in the decreased form. And then now after this,
Yeah.
yeah, what they said, and then
Then it remains stationary.
for the next 5 seconds, let me just go back again. This I have to plot till 55 or 50, 50 or 55. At time t equal to 45 seconds, the car starts to deaccelerate, and at time t equal to 55 seconds, at time t equal to 55 seconds, and at a distance of 400 meter from the starting point, the car stops. Isn't it? I have to proceed this curve till 55 seconds,
Yes, sir.
like this. And for the next 5 seconds, they said it remains stationary.
Straight.
If I'm not wrong,
Yes,
then
sir.
this will be a graph like this. The car is at rest for the next 5 seconds, and if it is at rest, then there is no change in the position of distance. So this line, this portion for the 5 seconds is showing that the car is not moving, but it is at rest position. So this graph you have to plot in this question. Question number 2a, I'm not taking, that is a simple question. And then, okay, let us discuss the B part. And in B part, the mass is given. Golf club is in contact with the ball for this time, and the ball leaves the golf club at a speed 65. Calculate the momentum of the ball as it leaves the golf club. Momentum of the ball. Momentum the ball at it leaves the golf club. What will be the momentum, children? Momentum is given by the equation mass multiplied by velocity. Mass of the ball is 0.046 multiplied by velocity 65. As it leaves the golf club, the speed is 65. Please someone multiply.
Sir, 2.99.
Let me check the answer also. 2.99 here in the marking, it is 3 Newton seconds. So 2.99 you can write equal to 3. So 3, what about the unit? Mass in kilogram, velocity in meter
kg
per
per
second, or
kg
there
meter
is
per
another unit also in Newton seconds. Second part, now there is another one. The average resultant force acting on the ball when it is in contact with the golf club. Resultant force. There is a contact of a golf club with the ball for a time period of 5 times 10 to the power minus 4 seconds. So during that period, how much is the average force is acting between the ball and the golf club? That is the meaning of this statement. You have to calculate. So that average force is calculated by what? What equation? Tenth class children. Trisha. Trisha and Harshan, both of you. Average resultant force. Trisha and Harshan.
Subject mass over average velocity.
You're saying mass over average velocity, this one. I had never seen this formula. Yeah, I received one answer from Meher is saying that F equal to M multiplied by
mass
V
into
divided
acceleration.
by time. Yeah. So that is a mass into acceleration. You can use the equation. There are many ways to do this question. F average is given by mass into acceleration. F is equal to given by delta P by delta T, rate of change of momentum. So both of the equations are applicable. Let me use this equation. Average force is equal to mass is given. Here you can see here mass is 0.046 multiplied by acceleration. Direct acceleration is not given, but you can calculate the acceleration by the equation change in velocity upon time taken. Okay, then in the next step, 0.046 multiplied by v minus u, the difference in the velocity. Object was at rest and moves when is hit by the golf club, and then with the velocity 65 I can put here. And what is the time taken here? This is given in the question, 5.0 times 10 to the power minus, and you have to do this calculation in calculator. Please do and tell me the answer. Yeah, Harshan, F equal to m into a.
So the answer is 5,980 newtons.
Yeah, in the marking scheme, this is nearly 6,000 Newton. 6,000, can you write it like 6,000 Newton, Anirudh?
Yes.
6,000 Newton is whatever you are getting your answer in your mobile phone in calculator, you have to write that answer in exam.
Sir,
Yes, Kashvi.
for the exam on the 21st, is the paper gonna be difficult?
This type of questions.
Okay, sir.
Uh, State the type of energy stored in the ball during its contact with the golf club. Okay,
Sir,
Harsha.
is it
Pari, I want to hear answer from Pari.
So elastic.
Yeah, there is the ball becomes compressed due to the average force is acting on the ball for a short period of time, and then this is due to the elastic potential energy or the strain, or as Pari said that the elastic energy, can use the word elastic energy, children. Yes, and Ruth answer is correct. Question is also correct. You are aware about the waves, children? These questions.
yes?
Wave questions are simple, but just let me write the equation. As what equations you have to remember? V equal to frequency multiplied by lambda. This equation. Most of the wave questions, when the speed is given, some distance is given, means the wavelength is given, you have to use this equation to calculate velocity, frequency, or lambda. Two values will be there. Third unknown value you can find with this equation. What do you mean by transverse wave? What do you mean by longitudinal wave? That you have to remember. I can try to plot a graph. Draw a diagram that represents a transverse wave traveling from left to right across the page. On your diagram level, wavelength and the amplitude. So here, if I draw, this is the mean position, and something like that. A wave is traveling from left to right. You have to mention what? Amplitude. Where is the amplitude?
Amplitude.
The maximum displacement of the particles of the medium from the mean position. This one. This is called amplitude. Let me write with the letter A. Where is the wavelength?
Sir, the distance from one crust to another crust, or one trough to another trough.
Yes, there are many point way to represent a wavelength. The distance between the two consecutive crusts or trough from their main position, from the high position. This one. This is lambda. Even lambda you can also mention here. This one is also lambda. There are many way to represent a wavelength. Even you can start from this point and this point. This is also wavelength. A complete length of a wave is called wavelength. One crest, one trough is a one wave. Okay, this question is not required, not. Do you know thermal capacity, children?
Wait, so I think we need to do revision on this.
Thermal capacity basically is, if I write an equation, I will explain this from Q is equal to mc delta T, this combined factor, M into C, that is called the thermal or heat capacity. So basically heat capacity or thermal capacity, thermal capacity is given by Q divided by delta T. Yeah, this equation, Q divided by delta T. So you have to write the equation, means statement, sorry, amount of heat given to a substance, heat given to a substance by raising a temperature by unit degree Celsius. Amount of heat given to a body to increase its temperature by 1 degree Celsius. That is called heat capacity. So again, from this formula, you can make a statement for heat capacity. And now if we know the definition of heat capacity, then the next question is again calculate, you need to calculate the thermal capacity of the wood burning stove. Specific heat capacity of iron is given. You need to calculate what? It's a very simple question,
Thermal
children.
capacity.
Yeah, you have to
We multiply that with 85
you
kilograms.
have to multiply. Yes, you have to multiply with mass. Basically, if I use a letter thermal capacity represented by capital C, this is equal to mass multiplied by specific heat capacity, small c. Small c is specific heat capacity, children. Capital C I have taken for heat capacity or thermal capacity. So capital C equal to m into c. In the question, small c is given, specific heat capacity, that 460. You have to calculate what? Thermal capacity. Thermal capacity means you have to calculate capital C. Capital C is given by mass multiplied by C, small c. Mass is, and you said 85. 85 is given multiplied by small c, and you can multiply. That is the answer.
39,100.
And what about the unit? Kashvi, may I know the unit? Unit is also important. Thermal capacity unit. Kashvi.
Joules per degree Celsius.
Now you can see, children, what will be the unit. We have calculated C, which is equal to mass multiplied by small c. Mass having the unit kilogram. C unit is given here. You put all these values. Joule divided by kilogram and divided by degree Celsius. Kilogram cancelled by kilogram. What we have left?
Joule per degree Celsius.
Yeah. So this is unit. Correct. Yeah, this light question also I want to discuss with you. Figure this shows a white light consists of 7 colors, violet to red, with Gior, and shows a white light incident at point X on a glass prism. From point X on figure 6.1, draw a ray of red light labeled R and a ray of violet light labeled V. Show how a spectrum is formed on the screen. Okay. This is a white light incident at point X, and now at point X, what happens?
Refraction.
Refraction will take place. The white light, it bend, and how it will bend?
Wait, sir, diffraction and refraction will take place.
Yes. And then what happens here? I will take that I need to represent the red and the violet color. So red color has the highest wavelength, it bend least. So suppose this is the red light is going, Violet color is suppose this is the violet color I'm using. Violet band the maximum, and it will reflect, and it will be here. This is the violet color, and this is the red ray of light. So this kind of diagram, and apart from the violet and the red, there is Vibgyor, Vibgyor. So indigo will be there. So rest of the colors will be there in between red and violet. Remember, children, you have to show the refractions at this point. Sometimes the student make a mistake. What kind of they make a mistake? They pass the light here and by single ray, then here they show the 7 colors. That is wrong. Refraction take place exactly at the first face of the prism, and then you have to proceed with the all other colors. Shortest wavelength is with which color? What color has the minimum wavelength? And this question is for
Violet.
what island? Or Thailand?
Violet. Violet.
Uh, violet color has the shortest wavelength. Yes, you have to remember this value, and the red color has the highest value of wavelength. Question number B, the critical angle for a type of glass is there, 42. Mohammed Kinan, are you here? Are you back? Mohammed, okay. So Pahel, please be ready for this question. Pahel and Meher, both of you. And if you look at the diagram, figure 6.2, 6.3 shows two prisms ABC, PQR made of this type of glass. A ray of monochromatic red light pass into each of the prism. Now the first question is for Meher. What do you understand by the term monochromatic? Monochromatic.
Monochromatic light is light with a single wavelength.
Yes, correct. Yeah, monochromatic light is a light having the single color, a single wavelength, or a single frequency. That is called a monochromatic light. A single color, a single wavelength, a single frequency is called a monochromatic. Now the same question for again Meher and Pahel, and that is, remember that the critical angle is 42 degree given, and so Pahel, now may I know that in the prism ABC, what is this? Can you give the name of this light? What phenomena is taking place here in the prism ABC?
It's a total internal reflection.
Please prove it that this is the TIR.
Because the angle is greater than 42 degrees.
May I know the angle of incidence in this case, Pahel?
45 degrees.
45 degree, yes. This is the 45 degree because this is the normal angle is 90 degree and 45 is here, and the remaining angle is also 45. Angle of incidence I is 45. So this angle I is 45 and the critical angle is given, which is 42 degree in the statement. So angle of this is critical. If I is greater than critical angle, that is the condition for that the total internal reflection to take place. So that's why, and again, if the angle of I is 45 degree, so light will reflect, and this angle also, this reflected angle is also 45 degrees, and that this is the total internal reflection. And what happens, this type of questions come in grade 11 and 12. What happens, this ray will pass or not, so you can practice this one also. What happens with the reflected rays with the prism, with the base of the prism. Now the next part for the Meher. So this question is for Meher and Jordan. Both of you please get ready, and Abhi and Kartikesh, you also. In figure PQR, what's happening with the incident array? What phenomena is there? What phenomena? Jordan, what is this? This one, what is the name given to this ray that passes from the prism into the same medium? Air.
Outside the medium, sir.
Yeah, outside the medium.
Refracting.
Refracting, yeah, refracting, or just refraction is there. So this is the refracting rays, or refraction is taking place. And Abhiyadav, what about this ray? That is this one. Is there any name given to this ray? Abhiyadav, Abhi is not replying. Then Karthikeya Shai and Anki Sharma and Atharva. Ankit, Ankit, Abhi, Atharva.
Uh, uh,
Anki Sharma, you need to change your internet connection.
it, I
Harshan said outside is the reflecting, inside is the reflection.
Reflected ray.
Yeah, reflected ray. This is a some part of the ray. Most part of the light is reflected, but some part of the light is also remains in the medium. That is called the reflected ray. And this is not a total internal reflection. If it is a total internal reflection, then once total internal reflection take place, nothing will come out in the there is no reflected rays. So please remember here in this point that the name given to, suppose this is YP, the name given to this YP is reflected ray of light. Okay, Ankit, no problem. Yeah, that I can understand that if many people are using the internet, then there is a problem. Next question. Okay, question number 7. Please read it first part, children. What is this name? D
Defibrillator.
defibrillator is a machine that sends this is a bio word. I hate bio. A defibrillator is a machine that sends an electrical charge through the heart of a patient whose heart is not beating correctly. Yeah, in the movies I have seen, doctors they do. Doctors learn to use this machine by practicing on a medical dummy. Figure 7.1 shows the two contacts of this machine attached to a medical dummy. The contacts that touch the dummy are made from metal. Read this statement carefully, children. Contacts are made from metal, and when the defibrillator is being used, one contact being strongly negatively charged and other is positively charged. Handles of the contacts are made from plastic. Yeah, that is understood. It should be from plastic. Otherwise, the doctor will be at the position of a dummy. From the structure of a conductor. Now, what you have to find out, children. State how the structure of an electrical insulator differs from the structure of a conductor. Did you get my point, children? If the handles are not of
Yes.
plastic, other than the doctor will be at the position of a dummy.
Yes, sir.
Yeah. So then apply this concept, children.
Sir, so the defibrillator should be, the handle should be an electrical insulator, because when the charge is passed to the metals, it should not reach the handles.